Right guys, now we're going to do quadratic inequalities. So remember, when you do quadratic inequalities, it's exactly the same as solving for x, but it only deals with number lines or parabola. So quadratic means it's x to the power of 2, so the graph that would be drawn would be a parabola graph. So whenever you get an equation like number 1, step number 1 is take everything onto your left hand side and solve the equation like normal to find your critical values. So we're going to say, right, all the things are on the left hand side, so you're going to open brackets, close, open, close, less than 0. We know this is the difference of two squares, so we're going to have plus 2, we're going to have minus 2. It doesn't matter which bracket you put the plus or the minus, it's the same thing. Then we're going to say CVs. CVs means critical values. So your critical values, so let me just write critical values are where x is equal to minus 2 or x is equal to 2. So we took each one of them and we solved it to find our critical values. That doesn't mean that's our answers, that's our critical value. After we get the critical value, we need to draw a parabola. So we need to draw either a happy face or a sad face. So how would you know if you're going to draw a happy face or a sad face? You need to look at your a value in here. Now in front of the x squared is a positive 1. This is a positive 1. So positive 1 is a happy face. So therefore my face is going to look like this. Happy. So when I draw a happy face, I'm going to put my critical values on each side. So the smaller number goes on the left hand side, the bigger number goes on the right hand side. And then now this is the part where many people get confused about the shading. So when you have something like this, and the question said it has to be less than 0. Less than 0 means below the x-axis. So this part here means below the x-axis. So when you have below the x-axis, that means what part of the parabola is below the x-axis. So if I look here, this is above, this is below, this is above. So this is my below my axis. So this is how I showed it graphically. But your final answer is not this. Your final answer is when you have to write it in set builder notation. So what am I going to do now? I'm going to say, right, this is between two numbers. So when it's between two numbers, my x must be in the middle. I must have a less than sign on one side and a less than sign on the other side. Now, what is very important is, here it says must be only less than. Did it say it must be equal to? No. So it said less than. So this has to be an open circle, and this has to also be an open circle because it's just less than. If it was equal to, we would have colored it in. So we're going to say x must be greater than minus 2. So so x has to be more than minus 2. Doesn't mean it is greater than minus 2, but it must be also less than 2. So all the numbers between minus 2 and 2 would be satisfying this equation. So my final answer will just be minus 2. X is greater than minus 2, but it must be less than 2. Very, very simple. Exact same thing. We do it all the time. Now let's go to the next sum. Right, so I want you to do the next sum on your own. So let me just write for you the steps, okay? So step 1, let me write it for you. Step 1, factorize. Right, step 2, you find the critical values. Right, the C values. Number 3, you determine if it's a happy face, so A is greater than 0, or it's a sad face if A is less than 0. And then number 4, then you draw the graph and see if above or below the axis, the x-axis. And finally, you write the inequality. So this is called an inequality. Right, so now let's start here. So x squared minus 3x is greater than 18. Our first step, factorize. So move everything to the left hand side. X squared minus 3x minus 18 is greater than 0. Then factorize, remember? So open, close, greater than 0. So I'm going to say what? I got an x and I got an x. what factors of 18 would give me, if I add or minus them, would give me 3 also. So I have 1 times 18, I have 2 times 9, nope, the difference won't give me 3. We have 3 and 6, okay, yeah, that will give me 3, so 3 and 6. Because it's a negative 3, the bigger number must be negative and the smaller number must be positive. A negative and a positive gives me a negative 18. So now I need to find my CVs. So my critical values are x must be equal to minus 3 or x must be equal to positive 6. Then I need to see, is it a happy face or is it a sad face? This is a happy face, so it's going to be like that. Then I need to say, right, draw the graphs. I need to plot the points. Here it is not an equal to sign, so it's going to be open. Then I'm going to say, right, what I have here, minus 3 and 6. The smaller number on this side, the bigger number on that side. Then I'm going to say, right, now see if it's above or below the axis. If it's greater than 0, it means above the x-axis. Right, then you're going to have above the x-axis. So what's your final answer going to be? Right, above the x-axis, you have to look here. This is above the x-axis. This is above the x-axis. This is below the x-axis. So my answer has to be less than minus 3, but it must be more than 6. So when I'm going to write the inequalities, I'm going to say this. X must be less than minus 3 or x must be greater than 6. So it can either be this or that. So that's my final answer. Easy peasy. Right. Right, number 3 you need to do on your own now. Pause it and do number 3 and follow the rules exactly like before, and you should be fine. Alright, let's start. So we're gonna rearrange this to be minus 2x squared plus x is greater than or equal to 0. Alright, we don't like working with negative numbers, so we're gonna say 2x squared minus x. And remember, when you divide, the sign changes, and this 0 divided by negative 1 is still that. Then I'm going to take out x as a common factor, and we're left with 2x minus 1 is less than or equal to 0. So my CVs is x is equal to 0 or x is equal to a half, because we're letting each one equal to 0. Then we're going to say, right, is it a happy face or a sad face? Now, you don't look at the original. You look at the step just before the CVs. The step just before the CVs, or this part here, it makes it a positive. So because it's a positive in that part, I'm going to say, okay, so it's positive here, and it's equal to, and it's equal to there. So make a color in the dots. Here I'm going to have a 0. Here I'm going to have a half. Now it says it must be below the 0. So it has to be here. So my final answer is going to be that x is greater than 0 and it's also equal to 0, and x is equal and less than a half. So it only goes between this part here. If I had to write this as interval notation, then my answer would have been like this. X is an element of square brackets 0 to a half square brackets. Okay. And for the one on top here, it would have been here, it would have been x is an element of negative 2, so open brackets, positive 2, open brackets. Here it would have been 2 separate ones, so I would have said x is I would have done it separately. So this one here, so I'm going to do it here. I would have said x is an element of negative infinity to 3, or x is an element of, we have 6 to positive infinity. That's how I would have written this one here. Right, so hopefully you are fine. Now I'm going to give you a few sums to do on your own, and let's see if you can do that. But before we get there, let's talk about some special cases. Alright, some special cases. So quadratic inequalities have some special cases. That basically means if I have a number like this, x squared plus 2, which is greater than 0. Now this you can't factorize, isn't it? You can't factorize. It's hard to factorize. But if I had to draw the graph for this, that means my y-intercept would have been here, which would also be my turning point. So that, and it's a happy face. So this would have been 2 here. Oh no, it looks like a devil's fork or something like that. Right, but anyways, this is how my graph looks. Does it have any critical values? No, there is no x-intercepts. So therefore, my solution will be x is an element of real numbers. It would have been x is an element of real numbers. That's how it would have been. So that means it lies above the x-axis for all the real values of x. So it doesn't cut the x-axis. Then if I had one like this, x plus 2 squared greater than or equal to 0, right? So if I had to solve this, I would have just gotten one answer all the time. X is equal to minus 2 as my CVs. So if I had to draw this kind of graph, that means at minus 2, oops, wrong direction, should have been this side. At minus 2, my graph only cuts it at minus 2. So if it cuts it only at minus 2, then it says when is it greater than or equal to 0. So this also too will be that it will be greater than or equal to 0 for all values of it. So it will be an element of real numbers also. Okay, that's how it would basically be. It will just be greater than and equal for all the values. So all of them would be at it. Right. Then if I just had greater than 0, right, so if I had one like this where it said x plus 2 is greater than 0. Now this is greater than, not greater and equal to. Greater and equal to, so you could include everything. But if it was just greater than 0, then it would be like this. X is an element of negative 2, right? I mean not negative 2, negative infinity to positive infinity, but x cannot equal to minus 2, because at minus 2 it would be touching the x-intercept. And they said it must not be equal to 0, it must be greater than 0. Right. Then if they say when is this less than 0, right, can it ever be less than 0? So therefore it's no solution. Okay, that's basically it. Or when they say when is x plus 2 squared equal to 0, when is it exactly equal to 0? It's equal to 0 when x is equal to minus 2, and that can be my only answer. So these are called special cases. Now I'm going to basically do for you a few sums. I'm going to give you it and you must do it on your own and see if you know how to do it. Right, some of you must be wondering why aren't I showing you the one where you have like this x minus 2, x plus 3 all over x minus 5 greater than 0. Now this, guys, is normal in the CAPS, in the syllabus, not CAPS. This used to be in the old syllabus before. Now it's normal in the old syllabus. It's normal in the new syllabus. It's normal CAPS. So if you see something like this, you must just leave it out, or not leave it out. You only work out the top part. Okay, just show that you got the critical values to be positive 2 and the critical values to be negative 2, and you can't do this part here because it's not CAPS compliant anymore. Right, so the sums I want you to do is, right, let's do this one here. So I want you to do 4x squared greater than 9, number 2, 3x plus 9 greater than 2x squared. Alright, then I want you to do number 3, let's see what you can do. I'm trying to find some hard ones for you. I think this is more than enough now. Right, so put the timer on for 6 minutes. Put your timer on for 6 minutes, pause this video and come back so you can do it. Right, now number 1, do the same step. 4x squared is greater than 9. So put everything onto the left hand side. So minus 9 is greater than 0. you must put everything on the left hand side, and the right hand side must equal to 0. Then factorize. So when you factorize something like this, can you see it's a difference of two squares? Square, square, minus square. I'm going to say 2x minus 3, and 2x plus 3 is greater than 0. So my CVs, which is my critical values, are going to be x is equal to 3 over 2, or x is equal to negative 3 over 2. Then I'm going to draw my happy or sad face. Now if you look here, it's a happy face. So I normally don't make this line in the middle because that's just in my way. I only just make the x-axis, and I make a happy face. And I say, right, it says greater than, not equal to, so open dots. Then it says above the x-axis. So what's above the x-axis? This is above the x-axis. That is above the x-axis. So my answer here is going to be is that x, right, so x can only be greater. Oh yeah, and I forgot to put my critical value. So 3 over 2 and minus 3 over 2 and 3 over 2 here. So my critical values are going to be so x must be less than minus 3 over 2, or x must be greater than 3 over 2. Right, that's my answers. If you got this correct, it's fine. If you do the interval notation, then you would have done it like this. X is an element of negative infinity to negative 3 over 2, or x is an element of 3 over 2 to positive infinity. Okay, then we're going to move to number 2. If you move to number 2, it's more longer. Alright, so number 2, 3x plus 9 greater than 2x squared. So what I'm going to do now is put everything to the left hand side. So minus 2x squared, right, plus 3x plus 9 is greater than 0. So what I'm going to do, I don't like a negative number, so I divide everything by a negative. So when I divide everything by a negative, I'm going to get here. Right, what I'm going to get here, I'm going to get here divide everything by a negative, so I'm going to get positive 2x squared, negative 3x, negative 9, less than 0. Right, now I factorize. Right, so when I factorize now, I say 3 and 3. So this times this is 6. So this must be negative, this must be positive, and I say my CV values is x is equal to negative 3 over 2, or x is equal to positive 3. So remember now, because I divided, right, I look at this part here. So when I look at this part here, it's going to be a happy face. And if I have a happy face, I'm going to have, and it says here open, so it's not equal to, so it's open. Then I'm going to have negative 3 over 2, and I'm going to have positive 3, and it says here it must be less than 0, so it's in between here. So my answer is going to be x must be greater than 3 over 2, or x must be less than 3. Right, that's your answer. Interval notation will be written like this. I'm going to write it here. X is an element of open brackets 3 over 2 to 3. Okay, then we're going to do number 3. Alright, we go to number 3. Now many of you thought, oh wow, number 3 is so easy, it's already done for us. If you thought that, you already got 0. The reason why is you can only let this equal to 0 and this equal to 0 if this part here was 0. But here it's not 0, here it's 12. So you first have to multiply this thing out. So x squared minus 3x, right, minus 4x plus 12 is greater than equal to 12. Put everything onto the left hand side and simplify. Minus 7x, 12 and 12 cancelled out with each other. So I will left with 0 on this side. Then I took out x as a common factor, so x minus 7 greater than equal to 0. Now when I draw my graph, my critical values are going to be x equal to 0 or x equal to 7. So here it's going to be 0, and it's going to be cut it in because it's equal to, and here it's going to be 7, and then it says above, so it has to be here like that. So I'm going to say x is less than or equal to 0, or x is greater than or equal to 7. Right, that's my answers. If I write this in interval notation, it'll be like this: x is an element of negative infinity to 0, but it must be closed, or x is an element of square brackets 7 to positive infinity. Right, that's your answers. Right, hopefully you did well. Right, all the best for the exams. Yay!